Hi guys, this is Jonathan Lambert with Maths and Stats, and in this video, another video in our series of videos dealing with polynomial functions, and in particular using the rational root test to help us to solve cubic equations. We're going to look at a specific. We're going to cover a particular example in this particular video that shows you how to use the rational root test to solve cubic equations. So let's just say that we have a function. Let's say consider the function. Let's say the function is x cubed minus 7x plus 6 equals 0. The first thing to note about this is that we can't solve this particular function using the grouping method, okay? Because when we group the minus 7x and the 6, first of all, there's nothing in common between the minus 7x and the 6 other than 1 or minus 1. And when we try to group over here, there's no x squared term, so we're not going to be able to use the grouping technique. But what we can use is what's known as the rational root test. The rational root test, and the rational root test basically says this. It says that if we have a particular polynomial, let's say it's a cubic, so it's of the form a3 times x cubed plus a2 times x squared plus a1 times x plus a0 equals 0. Now you can actually see that this polynomial is in this particular form. The coefficient of the x cubed is 1, so a3 is 1. There's no x squared term, so that means a2 must be 0. The coefficient of the x in this case is minus 7, and the constant term, the a0, is equal to plus 6. And what the rational root test tells us is that possible roots, okay, of the polynomial, function, right, that the possible roots of the polynomial function are plus or minus the factors, okay, so the factors of a0 divided by the factors of a3 in this case. So actually this rational root test extends to a polynomial of any degree, where in general it says that the possible roots of the polynomial are plus or minus the factors of the a0 term divided by the factors of the an term. So that's the coefficient of the highest of the x that has the highest power. In our case here, this is a cubic. You can actually see that a0, the constant term, is 6. So using the rational root test, we have that a0 is equal to 6. Okay, it's equal to positive 6. And we have that a3, which is the coefficient of the x cubed term, a3 is equal to 1. Okay? So what we're going to do is, first of all, is we're just going to list down all the factors of 6. Okay? All the factors of 6 are 1, 2, 3, and 6 itself. All the factors of 1 are, no, obviously we have plus or minus, if that makes sense. We have, that's what we're going to capture here, is all the plus or minus terms. So let's just list all the positive ones. So then the factors of 1 are simply just 1. So all the possible roots, okay, of this particular polynomial are all the possible combinations. So they're going to be plus or minus the first factor of a0, which is 1, divided by the factors of a3. There's only one factor of a3 here, which is 1. So it's basically plus or minus 1. The next factor is going to be the next factor of a0, which is a 2. So it's going to be plus or minus 2 over a3, which is 1. It's going to also be then plus or minus the next factor of a0 is 3 over 1, followed by plus or minus 6 over 1. So they're all of our possibilities. So you actually see that there's a possibilities, yeah. Okay. So the possible roots, okay, the possible roots are elements, yeah, are elements of the set 1 minus 1, 2 minus 2, 3 minus 3, and finally 6 minus 6. They're the only possible roots based off the rational root theorem. Okay, so let's see. What we're going to do now is we're going to see which one of these particular values, when we substitute